Hello everyone, this is section 6.3. Again, before I start the lecture, I just want to remind you guys about the way we assign homework of section 6.2 and 6.3. Well, today's lecture is going to be over 6.3. So yeah, including the lecture I did last week, 6.2, plus this Monday lecture, today's lecture. The homework for these two will be due this coming Saturday, which is November 14, 11:59 p.m. All right. Okay, now let's start this section 6.3. So 6.3 is basically, well, it's everything I'll be talking about here in this section will be just the revision of what you guys learned in algebra. All right, so I might just skip something, or I will just quickly review the things that you guys learned in algebra. All right. So this is logarithmic function. Okay, so 6.1 was about exponential function, right? So exponential function and logarithmic functions are related. So let's first introduce exponential function. So we know the exponential function form is y is equals to b to the power x, where b on the power is greater than 0 and it's not equals to 1, right? And we said this is an exponential function. Let me just write xb, which means exponential function. All right, and then so the logarithmic function is the inverse of exponential function. So again, if you go back to 6.1, I talked about how to find the inverse. Okay, so now to find inverse of this function, so the first thing I can do here is change this y to x and x to y, right? Or basically interchange y and x. So y, change that y to x and x to y. Or let me just write it like this: b to the power y is equals to x. All right, now after this, now we need to solve for y. So now we still have this one is still exponential function, right? Because we still have this b is on the base. Now, now the way we change this one to a logarithmic function is, I'm pretty sure that you guys learned this in algebra. Again, this is going to be a review. So the way we get the logarithmic function from here is the thing that we have on the power y is equals to, now we can introduce log base. So this base b of an exponential function is also going to be the base of log. So b, which is going to be on the base, on the bottom of log, and of x. All right, so now this one we say this is a log function or logarithmic function. Okay, and again, the same condition for this one too. So b must be greater than 0 and b cannot be 1. All right. Okay, now now let's see some properties of log. Okay, so some properties of log. Okay, so the first one, well, let's see if we have log base b. Okay, this b is in the base and of b to the power x. All right, so this one is in the base, log base b of b to the power x. So here, these two are same, right? B and b. So in this case, if these two are same, the value of this whole thing will be whatever we have here in the power. This is equals to x. All right, so which means, let's say if we have log base 3 of 3 to the power 2. So that means these and these, well, these two are same, right? Just like this. So that means the answer is the value of the whole thing, the value of whole thing is 2. Similarly, let's say if you're finding log base 4 of 64. Okay, so what is the value of this one? What is the value of this whole thing? So the value of this whole thing is, well, now, well, we just have 64, but we can change the 64 to 4 to the power something. So that way we can make 4 and 4, right? So what I can do here is 64 is also 4 to the power 3, right? Because 4 to the power 3 is 64. So that means here now we get 4 and 4. So the value of this whole thing is 3. All right, so yeah, that's the idea. Okay. The second one, let's say log base b of 1. So what is the value of this one? So log of any base, all right, as long as base satisfy this condition, any base of 1 is always 0. So basically log of 1 is always 0. Okay. The next one, what is the log of 100? Okay, so here there is nothing on the base. So if there is nothing on the base, then it's always 10. So we don't have to write that. Okay, it's just like if you just write 2, that means the power is always 1, right? We don't have to write that because 2 to the power 1 is always 2. So it's similar concept. Here, if there is nothing on the base, then it's always 10. Okay, so you don't have to write that, but just to show you guys. Okay, so log base 10. 10 to the power, well, yeah, so 100 is also 10 to the power 2. So that way we have these two same. So the value of this whole thing is 2. Okay. All right, so another one. So let's say if we have single log, let's say base b again, m times n. So these two are two different things which are multiplying each other, all right, with the single log. So in this case, we can, this is also same as log base b of m plus log base b of n. All right, so single log with these two multiplying each other, we can we can say, well, yeah, we can divide this into two different log, okay, with plus sign in the middle, right? This is a property. So let's say a log base b or log base of something 10. All right, so this one also we can say log base b of, well, 10, we can even write 5 times 2 or 10 times 2, but just to give an idea how we can use this property here. So 5 times 2, this is also log base b of 5 plus log base b of 2. So we can even say this, right? Or we can even go another way. So let's say if we have log base 4 of 2 plus log base 4 of 32. So this is also same as, so if we have two different log with the same base and the plus sign in the middle, this is similar to this, right? So if we have that, then we can combine this to a single log, right? Single log with that base, whatever base we have, and just multiply these two, 2 and 32. So 2 and 32 times 32 is 64, right? And just like I showed before, this is also 3, right? Yeah, this is also 3. Okay. All right, so the next one, log base b of m divided by n. So probably you guys already know this one as well. So here, if we have single log with these two dividing each other, then this is going to be log base b of m minus log base b of n. all right? So, so again, it's a similar idea. It's a similar idea to this. It's just that now we have, if there is a division, or if there are two things dividing each other, then we can divide this into two different log with minus sign, all right? So let's say if we have log base 2 of 4 minus log base 2 of 2, then, well, since there is a minus and there are two different log with the minus sign in the middle with the same base, then I can combine this to a single log and just divide 4 and 2, which is also log base 2 of 2. So this is, well, this one I can write 2 to the power 1, right? So that means log base 2 of 2 to the power 1 is just 1, right? Okay, now another one. Log base, again, let's say b of m to the power k. All right, log base b of m to the power k. So this is also, we can even say, okay, this is another property, all right? So now, in this case, this thing on the power, we can bring this down here. Okay, so this is also k times log base b of m. Okay, so let's say if we have log base b of 25, then we can even say log base b of 25 is 5 to the power 2. So this is also same as, well, similar to this, where I can bring this down here. Or we can even go opposite way. All right, so if we have something like this, then we can move this up here and we can get this. All right, so we can go either way, either this way or this way, same thing, all right? Okay, so that's the idea. So probably most of you guys know these things, or even if you don't know it, okay, this is the idea of exponential function, or properties of exponential function. Okay, now there is another one where we call this one natural log, or natural logarithmic. Natural logarithm. All right, so the natural logarithm is, okay, so natural logarithm is basically ln, or instead of saying ln, normally we say this natural log, all right, math. So ln is same as log base e, all right? So if you go back to, again, 6.1 or 6.2, e means it's some value, right? 2 point, I don't remember, I think it's 1 something, I forgot. But yeah, it's a number, right? So whenever you see ln or natural log, that means this is log base e. Okay, so if we have log base e of 5, then we can even write this as natural log of 5. Okay, basically we're replacing log base e by natural log. Okay, so that means if someone asks you the value of natural log of e to the power something, let's say 3, what is the value of this one then? So this one, we know that ln, we can replace natural log, or ln, by log base e, and e to the power 3. So that way we have these two same, right? So that means the value of this one is 3. Okay, so that's the basic idea of natural log. Okay. All right, now what can we do? Okay, one more thing. So let's say if we have e to the power natural log of x, what is the value of this one? So probably you guys assume x, right? But why is it x? So the idea here is e to the power, well, this whole thing is in the power. So ln, we can even say natural log of e of x. So again, there is a property where we can say that if this thing on the base and the base of the log, if these two are same, then the value of this one, the whole thing is x. All right, this is also another property. Okay, so okay, now since we have gone through most of the properties, so now let's solve few things here. Or before we solve, let's say, okay, let's do one thing. Okay, let's say if we have log base a, or two times log a plus 1/2 log b. Well, base, there is nothing on the base, so that means the base is 10, but you don't have to write that. Now, what we got to do here is combine this to a single log. All right, let's combine this to a single log or single logarithmic function. Okay, so now here, we know that one of the property I explained here, I can basically move whatever we have up here, right? We can move that up here. So what I can do here is I can move this up here. I can move this up. I can move this up here, right? So that way now I can say that log base a square plus log of a square plus log of b to the power 1/2, right? So now since we have plus in the middle, I can combine this to a single log and just multiply a square and b to the power 2, or b to the power 1/2. So b to the power 1/2, I can even write that as square root of b, right? All right, so that's how we combine. Or we can even go the opposite way. So if this thing is given, and if you're asked to expand, so that means you just go opposite way and get that. All right. So from here to here, we say combine. From here to here, we say expand. All right. Okay, now let's. The reason I'm going quickly on most of the things, or it's just basically the review of what you guys learned back in previous classes you took. So that's why I'm going quickly over this thing, just to review things. All right. Okay, now solve. Let's solve. Okay, so solve this one. How do we solve this one? Okay, so now to solve this one, all we gotta do here is change this log function to exponential function. So if you go all the way back to the first, okay, so first one, so from here to here, I changed an exponential function to log function. Okay, if you just go opposite way, then you're changing log function to an exponential function. So what we do is, so if you see here, or let me just write it this way. So if you want to change this to an exponential function, all we got to do is move this base here. Okay, so that way we will get x is equals to b to the power y. So basically we are moving this base of log to the base of an exponential function. All right. So on the left hand side, okay, log is gone because basically we're changing now log to an exponential function. So just have x on the left hand side, and on the right hand side b to the power y. Okay. Okay, so same idea. Move this here. So on the left hand side we just have x. On the right hand side we have 2 to the power 3. So 2 to the power 3 is not 9. All right. Or I see most of the people write 3 to the power 2. Be careful. Okay, this 2 is going to be on the base. Okay, so 2 to the power 3 is 8. Or how do we solve e to the power 5 minus 3x plus 10? So it's now we have an exponential function. So now basically the idea is changing this exponential function to a log function. So the way we do that is, again, going back to whatever I explained here. So to change an exponential function to log function, on left hand side, anything on the base y is equals to log. This base is going to be the base of log of x, right? So same idea here. Okay, so here this thing on the power will be on left hand side is equals to log base. Okay, this e is also going to be now the base of log base e of 10. All right, so that means I can even write this as natural log of 10, right? Because log base e is natural log of 10. Now to solve this one, well, I guess you guys can do it. So it will be 5 minus log of 10 is equals to 3x. Now divide 3 on both sides. So 5 minus natural log of 10 over 3, right? Okay, so yeah, these are well, this lecture is basically just a review of algebra. So now 6.4, the next one is going to be the derivative. All right. So I will be talking about the derivative in 6.4, or the derivative of or derivative and integration both. Of logarithmic function. Okay. All right. So that's all for this video. All right. Thank you.